quickly go through the answers, and then anything you have trouble with, we will go over those problems more in-depthly. So again, the final line is your answers, and then anything you need to see beyond that, we will go over. So here's number 3 and 4. Yes, Ayako. You can in number 3. That's about the only one you can, because the power of this one's 1. But like in these two up here, since these were the powers of 3 and 2, you can't. So you don't, I mean, you can and you don't have to. It's totally a choice. Okay, 5 and 6. Okay. Seven and 8. Nine and 10. Eleven, 12. Thirteen and 14. Sorry. Alright, good on 13, 14. Are you still checking? It's going to black out for a second. I'm going to turn down the one light so it's easier. 'Yeah. Anything extra copied-wise is over there. I think the front was like a 3.6. It was was it stapled? It was. It probably is to the right of those, I think. I was out those 2 days before. Me as well. I left my copies here Wednesday and then wasn't allowed back. I did not have it, just so we're clear. I said I wasn't here those 2 days, but I did not have it, just so we're clear. Okay. 16. So again, the biggest thing you have to watch is your signs. So again, creating that common denominator, having everything multiplied together, dropping down your negative exponents, and appropriately grouping and canceling. So there's quite a bit of work that, would happen between here and here. So again, this is kind of like, okay, what's my first line? What's my final line? Okay, 17. And 18. And if I ever move down too quickly, just let me know. Okay, 19. Okay, number 20. (21) and 22. (23) and 24. So again, are there any of those problems that you're just like, I absolutely have no idea how you did that. I cannot get that started myself, etc. Anything you want to see maybe worked out fully, worked out to a different extent? Sure, Caitlin? Sure. Is that the one you're going to pick too? Okay. I feel like that's kind of the tricky part of this part of the math is like once you get to a certain point, it starts to get a little tricky. All right, so 19, just out of curiosity from the two of you, what was your first thought process? Like, what did you do when you looked at this problem? Or anybody want to volunteer, like, kind of what their first thought or process was? Because I'll tell you mine after I hear yours. Go ahead, what'd you do first? So you left the -2 for your whole problem. Okay. So I personally see a negative exponent, and my immediate thought before I even would have done this problem would have been to turn that to a positive and to flip the inside. So if you have a negative exponent, it's really the same as saying 1 over that, which is really the same as just flipping your fraction. So I would have, before I even took my derivative, I personally would have rewritten this as 4x squared plus 1 to the second power over 4x to the fourth minus 3. Sorry. I should make it proper. To the second power. Like I would have treated it like flipping it and then making my exponent positive, so that now when I do my chain rule's not to this negative power. So that when you did the derivative, it now becomes a 2. What? Yeah, and then it becomes to the first power. And then now you take the derivative of all of the inside. So then it would have been ho d high minus high d ho and then upon doing that, that's kind of almost how you can see, like, here's the one that's cubed. And then you could distribute your inside and your 2 here as well. No. I mean, you wouldn't have to, I would maybe simplify just this part, because a lot of times they're not going to leave their answers with fractions and multiplying like that. The answer is definitely going to be over this value cubed, but they probably would leave their multiple choice answer like this, and then still maybe distributing on the inside. Pencil's really hard to see. I'm going to use a pen. No. Oh, no. So like on my test, I usually break it down into 2 parts. The first line of work is usually a majority of your points. So if it's like a 6-point problem, then the first line of work is usually 4 points. And 2 points for simplifying. And like, I'll look at some of your work in the middle and try to maybe catch your error and determine how much of the simplification you messed up. And then if it's a free response, where like the answer you get in part A directly affects the answer you need to get in part C, and you do part C correctly, but with the incorrect maybe equation from part A, I call that copying error. Not copying error, it has like a name, and AP does it as well, which is why I do it the way I do it. It's basically like a fluid error. Like if you got the wrong answer, but you do the next part correctly using that wrong answer, you don't lose your points totally in part C. Like you can get like the idea points maybe, but like the incorrect answer. Yeah. So it has like a name, and you know, right now I can't even like think of like what they call that, but like, oh, it has a name. It's gonna bother me that I can't think of the word. But yeah, you know what I'm talking about, because most of you took stats or are in stats, but that's kind of the way that goes. Okay. I have another worksheet for you. Oh man, okay. Hold on. This chart basically walks you through how and all of the work for all of the answers. But basically, if you have function composition, my first advice is to always find the derivative of the functions, like I did in your note guide, then plug in the numbers, and then work it down to a final answer. Okay, number 2A, it's super hard to see some of these. I wish I could, like, highlight. Maybe I can't highlight them. This one? Okay. So, just because it got, like, kind of messy in here?
I wasn't quite sure how to split it with the 3 functions.
Same thing. So, guys, when you're doing your chain rule, the basic idea is you're working outside in. So like as you do this, so since the outermost function is g, we're going to take g prime first and not change anything inside. So inside, the f, the g, and the x are all going to stay identical. Then you ignore g prime now. It's done. G is done and over with. Now you're going to look at F, and you're going to get your F prime. And then after you keep all the inside stuff, you're going to do it again, and then you're going to do it with G and get your G prime. So like every value or function on the outside gets derived, but the inside stays the same until you get to the next function. Does that help everybody? Sure. So for x squared, guys, x squared is a function itself. So when you have a function inside a function with a function as what you're taking or looking at the value of, you have to take the derivative of x squared as well. So the derivative of x squared is 2x. That tags on because here the derivative of x is just like a 1. So it's kind of like when we did our problems and sine and cosines were just x's. Now it's the same holding true for this. You have your x squared and it becomes 2x.
I kind of just like thought that meant like the value squared and didn't take the derivative.
Gotcha. Okay, 3, part A, you get -1. And part B, we have this 1 over 12 square roots of 2. But again, if you kind of stopped here, just get that fraction of 1/3 down to the bottom. I don't need you to simplify root 8. But you cannot leave it as a fraction in a fraction. Okay, letter number 4, part A, you had -40 and part B, -4/9. Sorry, I'm just trying to see if I can mute it. I cannot. Okay, 5A is 60, and 5B is 6. This chain rule will allow us to now look at trig functions whose derivatives are greater than just an x inside. So up to this point, you've had sine x, cosine x, tan x, secant x, etc. Now we're going to look at trig functions where inside the sine, cosine, tangent, etc. is something other than just an x. So in this case, you have an x squared. So what that means is that the outside function is the sine. So the sine is my outer. It's my f. The inside function is the g of x. So the outer is f, the inner is g of x. So when you take your derivative, it's the derivative of the outer. So in this case, it would be the derivative of sine. So the derivative of sine is cosine. You maintain the inner. So the inner is x squared. And then what we do is we say, okay, we took the derivative of the outside, we kept the inside, and then we have to multiply or tag along the derivative of the inside. So in this case, the derivative of x squared is 2x. So the derivative of y in this case is 2x cosine x squared. Next, we have y equals sine squared x. So the outer function is actually not the sine. The sine is actually the inner function. The outer function in the case of this problem is actually going to be the squared. So the sine squared x is really the same as the sine of x squared. Or if you had to do it the old way, it would have been like saying sine x times sine x, and you needed the product rule. So the outer function is the squared, the inner is the sine. So when we take our derivative, the derivative of the outer is 2. The inner is that sine x. And then you multiply by the derivative of the inner, and the derivative of sine x is cosine. So this becomes 2 cosine x sine x. And if you wanted to see that, you could actually work that out. Yes. 2 what? Right, so the 2 is here. The x is like the sine. Okay, next example. Find the derivative of y equals 6 cosecant 10x. So once again, you have to recall your trig derivatives. So y okay, next. Alright, so it says find the derivative of y equals sine cosine. So your outer is sine, your inner